Good afternoon. This is Professor Ramanandan HS, Department of Mechanical Engineering, MIT Mysore. Today we are going to start a new module under the subject Mechatronics with a subject code of 17ME754. Name of the module is Mechanical and Electrical Actuation Systems. So, previous module you have seen the introduction to Mechatronics. So, now we will enter into actuation system part. Contents of, let us see the content of today's class, that is mechanical systems, introduction and examples, types of motion. Under the topic we will study something about kinematics, followed by cams, one of the important mechanical actuation system. We will study under that topic types of cams and followers, followed by one more important mechanical actuation system, ratchet and pawl mechanism. So, we will go one by one related to content, and you should always approach a subject, as I have already mentioned it, word by word. Let us go word by word. We will start with the first content, that is mechanical systems. So, already we are familiar what mechanical is all about. So, that is nothing but we usually discuss more on transmitting motion with the means of energy, power, source, pressure, acceleration. So, here we are dealing more with transmitting motion, energy, power, force, torque. So, that is all about our core part of mechanical engineering is about transmitting motion. So, think of lot of examples here. It may be a machine, it may be a machine tool, it may be automobiles, it may be any of the sector, it may be equipments. So, there you cannot even imagine anything without motion. You can just imagine even the hands also. There are fingers, there is a wrist, there are joints, where we have a complex set of motion. Even our finger can move, even in the finger you have different joints here, they can move at any axis, even they can move translationally as well as they can even rotate at any joint. I can even rotate around any joint. So, it is a combination of translational from one point to another and rotational. So, my hand can rotate in any of the axis, vertical axis, horizontal axis and all in 360 degree. It is a complex motion. So, a human body is also made up of different set of joints, links, levers, which makes us to have a motion which is translational and rotational. So, any motion can be easily broken down into these two. So, why I am speaking all of this is because you cannot even imagine any machine, maybe a lathe machine or drilling machine or shaper machine, it may be machine tools like a CNC machine, or any of the machine tools like a lathe or drilling, again radial drilling, various types of machines. There are various components which have motion relative to one another. As a whole they make a machine or a machine tool. So, as a mechanical engineer I should be having a clear picture of what a motion is. Then I will discuss something about motion conversion. So, motion is nothing but it is an act of moving. I have already told you motion is nothing but it is an act of moving or simply movement. So, act of moving I have mentioned earlier also. I have two types of motion here. Nature has two types of motion, that is translational and rotational. We have studied in physics. So, any motion can be easily broken down into these two. So, in case of your maybe washing machines or mixers or grinders, domestic purpose machines, or it may be machine tools which are used in shop floors like lathe or drilling machine or shaper machine. We usually see the spindle rotating, we see okay, the lathe head or tail stock, okay, head stock or tail stock, usually translating from one point to another, horizontal motion. We usually see the, okay, cross slide wheels, okay, rotating. Okay, we usually see something, okay, the tool post, entire tool post is gliding over the, okay, the bed, lathe bed. Okay, all these movements can be obtained. In drilling machine, we see, okay, the radial arm moving around the lead screw, the column. Okay, so all these motions, okay, are called as, okay, usually movement or act of moving. Okay, in any machine, I want, okay, my objective is there should be a mechanism which should help me in pursuing this act of motion. Okay, such motion converters, or which assist me in converting one form of motion into another form, they are called as mechanisms. Okay, I have marked here. So such things are called as mechanisms. So usually they are called as motion converters. Okay, if I tell you some of the examples, you will get to know: gears, okay, chain and belt drives, linkages, cams, rack and pinion, ratchet and pole. There are plenty of mechanisms. In automobile, we have used, okay, usually it is a chain driven, okay, transmission system, or it may be a toothed belt or belt drive driven system in gearless transmission. So what happens there? If you just imagine, or if you just go through a machine or an, okay, vehicle, you will see that the rotation is transmitted from one axis to another axis. Okay, if the rotation is happening in this axis, one of the axis, that is being, okay, transmitted to another axis. Okay, this is possible because of a chain drive or a belt drive, the transmission of motion. So that is why a cable or a belt drive comes under mechanism. So similarly, gears, what do the gears do? They help me in, okay, change of speed, bevel gears, worm gears, there are plenty of gears, helical gears, okay. So parallel shaft gears, you have plenty of gears, okay, available. So usually they assist me in change of speed, to vary the speed from, okay, one component or one shaft to another shaft. Okay. Similarly, you have, okay, linkages and cams. They help me in achieving particular type of motion. Okay. Cams are nothing but they convert, okay, motion into oscillatory motion, usually rotary motion into oscillatory motion. Okay. That is a function of a cam. Similarly, you have linkages. I have told you, links are nothing but, okay, there may be a rigid body or there may be any body usually which will pick up the motion and transmit it to the subsequent element with a little amount of deformation, okay, with a very negligible deformation, that is called as a link. So links are nothing but they are levers which are connected between nodes or the joints. You can see my arm here. So these are the joints. Wrist is a joint, elbow is a joint. So this can be called as a lever. So whatever movement of the hand I do, this lever as well as this lever between the elbow and the shoulder joint, it assists me in transmitting the motion. If I go to pick a pencil or if I go to pick a book from here, so usually these links will help me with a combination of, okay, movements, so that I do whatever the task assigned for me with my hand. Picking a book or picking an object, okay, having a pencil or writing with the help of a chalk piece, all this is possible because of these joints and this link between the joints. So followed by rack and pinion. Rack and pinion, usually we observe them in the, okay, watches, rack and pinion, watches, clocks, okay, any of the mechanisms where it will convert, okay, rotary motion into oscillatory motion. Okay. So rotational motion into a pulsed type of output, okay, usually linear motion or rotary to oscillatory motion is the function of rack and pinion. So like this, there are different type of motion converters to convert motion from one form to another. It may be, in case of your IC engines, the connecting rod is one such linkage. Okay. Piston and the connecting rod, you can just imagine connecting rod and the crankshaft. So the reciprocating motion is converted to rotary motion of the crankshaft. There also we have conversion of motion which is coming to picture. So mechanisms, they assist in motion conversion. Okay. So though we are talking about mechatronics, where we have included electronics into mechanical engineering to assist or to for data acquisition or for switching elements or maybe to control a device, still there is a need for the mechanical actuation system to exist in the mechanical system design. Say for example, a washing machine, just go through the operation there, water has to enter the drum. So for that, there should be a switching element, there should be a movement of water or pumping of water to the drum, and water should get cut off, later followed by heater switching on, or maybe spinning of the entire drum during rinsing cycle. So all these are nothing but there is movement being involved, or there is a flow of a fluid, or there is a motion being involved in washing machine. Take one more example of your automatic camera, where aperture, the thin film on which a photo should be appearing, the aperture should be fixed. There should be sufficient light exposure on the object as well as on the aperture. That should be set by the help of your range sensors and light sensors. We take the help of electronics, but all these motion should be the adjustment of the diaphragm, related to the proximity of an object to the camera. So all this requires a small amount of minor movement in automatic or your DSLR cameras. So where there is a very much necessity of a mechanical actuation system, where movement is involved, that something should move relatively to another. This makes us to study what are the existing mechanical actuation system and what are their uses. I have noted down few. You can see here the need of, I have already mentioned, I will just revise it with the help of few examples. For force amplification, you may need levers. For change of speed, I have told you, we use bevel gears for through change of speed through 90 degrees. Where in the four-wheelers you can see diesel engines at the rear axle, where the motion is transmitted from the axle to the wheel hub, that is transferred through 90 degrees with the help of your bevel gears. Then later part is a worm gear. You can see the change of speed that can be achieved with the help of gears. Next, your transfer of rotation about one axis to another, this I have already mentioned, with the help of chain and belt drive. So from the gears to the wheel hub, we will be in automobiles, we will be transmitting the motion from one axis. The chain will be usually rotating around one axis, that should be transferred to wheels, which are, though it is parallel to the chain, they both are at different axes. So this transfer of motion should be without any or with minimum losses. So that is possible because of chain and belt drive or toothed belt. So ultimately links and cams, I already mentioned, a particular type of motion for a prescribed manner behavior of the mechanism can be achieved by using links and cams. So this makes us to study motion, keeping in mind with the help of mechanisms to transfer the motion. So that part of physics, study of physics is called as kinematics, where I rely more on study of motion, least bothered about what is causing the motion. Always there are two things. If something is happening, there should be a cause for that to happen. Cause and effect, that is what we study in physics. Here we study only the effect, we don't study the cause. Force is the cause of motion. Okay, in kinematics, we study only motion without any regards to force. We hardly give importance to study of force. We study only what is the motion being transmitted from one point to another point. Okay. So, this branch is called as kinematics. By keeping in mind kinematics, we will next approach all the ways of mechanical actuation systems. So, you can see here first element, first important mechanism we have considered is cam. So, understanding about the cam, a cam is nothing but it will be having a pier shape. This is what we call it as pier. It will be in the shape of a pier. There will be three different zones. This zone is called as a rising zone. Bottommost with a constant radius is called as a dwelling zone. Dwell. It will be having a constant radius from the eccentric center. It is not exactly at the midpoint of the cam. Okay, this is called as the cam. It is eccentric center. Okay, eccentric. And this face is nothing but the fall face. We call it as fall in the cam. And above you can see here pointed type of fall layer with a reciprocating motion. Okay, this rotary motion will be converted into oscillatory. Okay, oscillatory or reciprocatory motion of the cam. Usually it is oscillatory. This part is called as fall layer. Okay, this part is cam. Cam will be having three zones: rise, dwell, and fall. So, all these will be calculated based on specific period of time, so that your second body fall layer should be always in contact with the cam profile. This profile will be always in contact with the fall layer, so that constantly the roller being moving with the help of the shaft, that motion is picked and converted into oscillatory by the fall layer. I repeat, constantly the motion of the fall layer is continuously picked by the fall layer of the cam, and continuously it is converted into oscillatory motion. So, this profile is usually defined for a specific period of time. Say for example, take your engine as an example. Okay, in the engine, valve should be open for petrol and air mixture to enter. So, what should be the period of time so that your petrol air mixture enters into your petrol engine? Okay, fix the period of time. So, that time will be defined by your cam profile, because valve does not understand, this is the amount of time I should keep the inlet valve open. Okay, that I will be defining with the help of the cam profile there, cam and the fall layer. So, this rise phase will be defining what amount of time the inlet valve should be open for the petrol air mixture to enter into the combustion chamber. Okay. So, there should be correlation between the profile generation of the cam, rise phase profile generation of the cam. They should be predetermined by the application what you want. Is that understood? So, dwell phase is usually inlet valve. What is the amount of inlet valve should be closed, because it is made up of constant radius. The amount of time inlet valve should be closed. Again, during the fall phase, the fall layer will lift the valve. So, inlet valve should again get open during the fall phase. Okay. So, like this the entire cam profile will be usually predetermined for a specific period of time for a specific application. So, rotary motion of the cam will be converted into oscillatory motion of the fall layer. So, this is first body and this is the second body. So, this is one form of conversion of motion, rotary to oscillatory. So, there are different types of cam. You can see here eccentric cam, where the center is usually eccentric, heart shaped cam, and then followed by pier shaped cam. Okay. So, you can observe there is a change in shape of the cam. So, change in shape I have already mentioned. The change in shape will usually result in varied displacement. S is nothing but the displacement, or the oscillatory motion. So, theta is nothing but rotation. So, rotation of the cam is x axis, y axis is nothing but movement of fall layer. Oscillatory motion is on the y axis. So, in the first case eccentric cam, you can see here Okay, rise phase, usually it is a simple harmonic motion. Graph is simple harmonic motion. Here, okay, motion of, so you can see, so this part is rise part, okay, this part is dwell part, and finally this is fall phase. Okay, from here to here it is fall phase, from here to here it is dwell phase, and from here to here, so this is rise phase of the cam. So depending upon the rise phase, you can see the movement of the cam. Okay, cam moves upwards. During dwell phase, it remains constant at this phase. It remains constant. At the fall phase, again, faller will again come back to its original position. So this is how the cycle will be usually defined. Opening of the valve remains open, and then valve comes close in the fall cycle. Okay. So similarly, displacement versus rotation for heart shaped cam. I have already told you the profile of the cam will usually define the whatever operation you want. So here heart shaped cam, you can see the radius is again playing a vital role here. The displacement obtained will be peak here. So this peak, it will reach peak. Here it is rise phase, here it is fall phase. So you can make out why the different types of cam profiles are generated now, depending upon the application. Similarly, pear shaped cam, you can see the dwell phase is okay, somewhat for a longer period of time. Okay, for a longer period of time it will reach the peak, and then again the fall phase will continue. So usually we prefer them for different types of applications. Similarly, you can see here the fall layers, cam fall layers are also of different types. Okay, this is about the cam, eccentric cam, heart shaped cam, and pear shaped cam. Okay, used for various purposes. So cam fall layers, you can see here, this is a pointer. Okay, they are defined by the point of contact to the cam. You can just observe the point of contact. It is sharp here, so it is called as pointed type of fall layer. So next comes here, okay, knife type of fall layer. Third one is roller contact. Here it is contacting the surface with a minimum surface contact. Okay, that is why this is more efficient, roller type of contact. Rolling friction is obviously too less compared to the sliding friction. So next comes D is here, okay, sliding and oscillating type of fall layer. This is flat type of fall layer, and last one is mushroom headed. Okay, it is mushroom headed type of fall layer. Usually the fall layer is the motion getting converted into oscillatory motion. So depending upon the what type of oscillatory motion I want, I will choose the cam fall layer surface. Okay, this is about the types of cam and types of fall layers. So next, second type of mechanism is ratchet and Paul mechanism. Okay, so ratchet and Paul mechanism, usually what it does is it converts. Okay, it is a holding mechanism. Okay, it is nothing but it is a holding mechanism. Okay, so I want to block a reading, analog reading. You have seen the pointer readings, cable type of odometers, as well as you have seen maybe in your clocks. Okay, wherever display comes into picture of analogous in nature, where there is a pointer, okay, and analog reading you can read in the display. So there ratchet and Paul mechanism plays a vital role because it is holding the pointer. It will not be continuously oscillating. The pointer will always be showing a precise reading at every point of time. How is that possible? That is possible because at the back end you can see something called as a ratchet wheel. So it is a toothed wheel. You can see various number of saw shaped teeth. Okay, there will be saw shaped hacksaw. You have seen the hacksaw blade. So similar to that, there will be a saw shaped teeth which will be usually cut on the ratchet wheel. Okay, it will usually shaft driven. So you can see a pawl mechanism, which is a pointed knife type of arrangement to hold the ratchet wheel against the rotation, to arrest the rotation of the ratchet wheel. If the ratchet wheel think that it is rotating clockwise, something like this, clockwise, okay, the pawl will usually arrest the motion in the clockwise direction. You can see here. Pawl is usually pivoted and it is connected with a spring. Okay. Spring is to assist the motion so that it should hold and again release. It should hold and again release the ratchet wheel at a particular reading. Okay. So continuously the ratchet wheel cannot rotate in the clockwise direction because the pawl is holding at a particular reading. There should be a force which is more than the holding force. Then only the pawl will be pulled by the spring, okay, back, so that your ratchet wheel rotates clockwise, makes one rotation or a smaller bit of rotation, and whenever the shaft stops rotating, your pawl mechanism again holds the spring force will become more than the force of the ratchet wheel. So that will stop the ratchet wheel rotation at that point. So this is how your pawl will act like a holding mechanism. Ratchet wheel and pawl will act like a holding mechanism for any type of analogous reading. Okay, usually it is used in displays of like it may be reflectors, or it may be odometers, or it may be clock, or it may be any dial gauge, pressure gauge. So where I want to read the, in case of pressure gauge, I want to read the value of pressure exerted in the, okay, any, maybe in the pressure gauge or in the load cell, I want to read the maximum pressure or weight. So that can be precisely read by using ratchet and pawl holding mechanism. Is that clear? Hope this entire content has reached you more effectively. So mechanical systems has furthermore, okay, number of mechanisms apart from this. So today we have spoken more on the introduction, followed by types of motion, kinematics, and then two types of mechanisms. One is cams and followers, and second one is ratchet and pawl mechanism. In the later part of the session, we will start discussing more on gear trains, okay, followed by chains and belt drives, okay, which are used for change of speed and, okay, transfer of rotation from one axis to another respectively in the next upcoming sessions. So hope this session has reached you more precisely and contently. Go through the session again and again for better reach. Thank you.